Hello and welcome to the first video on English on the CCESTE or CCESTE or CCESTE channel. I hope that you can understand a single word of what I'm saying. I will try to do my best to give you a concise walkthrough on this, and hopefully so you can override any subtitles that are being auto-generated by YouTube. And I'm speaking this on the fly, so there is no script, but I will try to do my best. So thanks for your time and apologies in advance if it's hard to understand. What are we doing today on this video? Our main idea will be to try to render configuration for existing and predefined devices here on Netbox. We will make use of two main sections on what we comprise inside Netbox models. First and foremost, we have a section named config context where we are defining some overall context that will work as some sort of global variable where we can set some pieces of information that we want to share among some predefined devices. For example, if you want to use the same set of NTP or DNS servers or the same set of SNMP communities, for example, on most of your devices, that will be some sort of context. So those devices share a context that is that everything is using the same kind of NTP server. So we'll be defining that kind of context in here. I won't be showing up that piece here on this video. You will find that on another video next on the station. But the overall idea is that you will be able at some point to store this config into a Git repository, for example, and be able to synchronize that data into Netbox so you can hopefully speed up the rendering of any future config that we are generating on the fly. What we will be doing today is make use of what Netbox is defined as config templates. In this case, I'm generating a pretty easy config for MikroTik v6 or router v6, whatever you want to name it. And the other idea is that we are using the power of Jinja 2 templates. If you are not familiar with Jinja 2, there is a video on my channel. I will leave the info card here on the top right. It's on Spanish, but probably YouTube is making a good work making the auto-generated subtitles for that video, so I hope you like it. And the overall idea is that on Jinja, we'll be defining the structure of what will be our configuration file. Of course, this will be absolutely dependent on the set of platforms that you're working at. It will be dependent on the software of the device that you're using and many other things that probably it's not worth your time trying to take care of every single piece, because probably whenever you're trying to overcomplicate things, the trade-off is not worth your time, and there is probably an easier way to accomplish the same. What is the overall concept of these templates? So we're making the skeleton for configuration here. For example, for loopback interfaces are defined as bridges without any assigned ports on MikroTik. In this case, what I'm doing here is I will take a look on every possible interface inside my predefined device here on Netbox. I will look out if that interface is a virtual interface, and I will look out if we have an IP address assigned to that interface, and if the role of the IP address I assign to that interface is a loopback. And why is that? Because I'm defining loopback interfaces, so I'm hoping that you are defining your loopback IP addresses as loopback, of course. Once I figure out which are the set of interfaces that I want to assign here, then I will be actually generating config for MikroTik. So in this case, we are using interface bridge. I will add an interface with a predefined name that will be pulling from the actual naming that we are using on a predefined device on the device section of the Netbox. Put in a proper description if there is one. So I will be putting a comment in here, and that's all really, because there is not much else to add for loopback interfaces. What about Ethernet interfaces? Here things get a bit interesting. So how are we detecting if we are declaring Ethernet interfaces on Netbox? I'm doing this, but that doesn't make sense that is the best way to achieve this. But what I'm doing is to figure out all the interfaces on my device and filtering if the type of the interface contains base. And why is that? Because you probably will find an interface that is 100 base T, and that's 100 meg Ethernet interfaces. So probably every single interface that you have defined as Ethernet, it will show up here. Be aware that this probably cannot detect every single possible type of interfaces. so it will be probably worth your time to make a bigger filter in here, but it depends on how much you want to complicate things at that point. So what are we doing here after we figure out what are the Ethernet interfaces we have defined on our device? We'll do exactly the same, setting the device, the interface name, and the description. And in this case, we can set the L2 MTU because it's an actual physical interface, and setting the MTU. And of course, we can set parameters like the duplex of the interface, either half or full, if we're using auto negotiation on that interface, and then the speed of the interface. I'm not matching every single possible speed in here, but I'm trying to do my best with 10, 100, 1 gig, 10 gig, 25, 40, and 100 gig. Of course, we are able to put those interfaces on shutdown. And you might want to keep this definition for the loopback interfaces, but come on, they are loopbacks. They're not supposed to go down at any moment. Anyway, what are we doing for bonding interfaces here? So exactly the same. Looking out all the interfaces on our devices and figure out if the type of that interface is a lag, a link aggregation. In this case, we are repeating ourselves, so adding the interface, the description, the comment, setting the MTU, and at being a lag, we can set the slaves or the members of those lags. I'm using slaves because that's how MikroTik defines the members of a link aggregation group here. We can also set the mode. In this case, we're using 802.3AD, standard LHCP. Remember that on MikroTik you have several other possible modes like balance RR for round robin, but it really depends on your specific use cases and everything. The transmit hash polishing, we can set this either to a specific hashing mode. I'm using a filter here to put that value as default on layer 3 and 4. And this will apply in the case if we are not setting any specific hash policy for our lag. And of course, we are considering the possibility of putting that interface on shutdown. For VLAN interfaces, the concept is pretty similar. We are repeating ourselves, comment descriptions, MTU, and of course, VLAN ID. So if our interface is comprising any tag VLANs inside, I will check. First and foremost, the first VLAN ID I'm seeing on that interface because I'm trying to create a single VLAN interface. This is not a switch port, but an interface. So we're expecting to have a single VLAN ID in here. But this might be a bit complex, but well, it's part of what MikroTik thinks it should be represented here, and is how it's represented inside RouterOS. Finally, we're putting IPv4 addresses in here. So what are we doing to accomplish the templating for IPv4 addresses? We are figuring out all the IP addresses that we are declaring on every single interface, and as long the address family of that address is IPv4, of course, we are putting an entry on RouterOS config. So we're putting to which interface that address belongs, the actual address with its .NET mask, of course. We can disable that interface if we want to, pay special attention to that part, and answer encryption if we need to. And then we are repeating ourselves for V6. So that's the overall concept, and you can check that I'm not implementing every single possible option here. This is just a mock-up, so you can follow along with me and have an idea of how we are actually representing config templates on V6, but I'm more than happy to share a full feature example if you want. I probably will put the link to a repo here below. And the overall idea is that we can apply this templating to a device now, because it's a template. It's the same thing you have on your desktop as a TXT file, but we are putting that inside Netbox here. I can quickly go to one of my previously defined devices. So in this case, I'm defining a CRS 328 switch here running RouterOS v6. Of course, remember that I have the option to define the platform for my switches here, and I'm assigning a config template that will be MikroTik v6 here. How am I assigning that piece of information to my device? Of course, on the device settings. Let me edit that device, and then I can first and foremost declare what config template am I supposed to use on this device, and be aware that's not related to the platform by any means. It's kind of platform depending. Of course, there might be things that you want to share between many different platforms, but you can quickly reuse config templates for things like ACLs, for example. So pay attention, special attention to that. It's just a warning that I have to make. Once we have declared that, there is another section where we can define an override to any definitions we put previously on the config context. For example, here, I said that I'm using layer 3 and 4 as the default hashing mode for my port channel interface, but in this case, I want to override that and make this layer 2 and 3. So I'm declaring an interface here manually as PO1, and I'm setting the hashing mode as layer 2 and 3, and this value matches to what RouterOS is expecting to show up on the command line. So this is absolutely platform dependent. And that PO1 is actually an interface that I already have defined and have added here as a link aggregation group. So the type of an interface is already a LAN. Once I have all that config, really the only thing I have to do right now is just hit on render config here, give this BPS a moment, and here's my brand new rendered config. So I have my bridge interface, of course, using loopback 0, which is the previous assigned loopback I created on the config templates, and the loopback I have here assigned on my device. I'm creating all my internet interfaces with the same naming convention I was using here on this device. I'm adding my port channel interface with the proper naming, proper mode, and overriding the default hash policy. I'm adding some VLAN interfaces because I had some VLAN interfaces defined here on my device, of course, setting the proper VLAN ID, name, interface where that VLAN should belong, and descriptions and everything and so on. And I'm adding a couple before addresses because I already had before addresses assigned to my interface. In this case, I have a loopback here and I have a address on my management VLAN. I would like you to tell me, why do you think those addresses are showing up as disabled here on RouterOS v6? So I know this is not a full feature example, but hopefully it can give you a good idea how is the workflow to achieve on-the-fly render of config context on Netbox. I hope you like this video. There will be more to come on the future days, and see you soon. Thank you.